angles in standard position. When we talk about the degree system, we're talking about measuring the amount of rotation. For example, take a look at this cool solar-powered car I built with my grandchildren. If I take the car and I rotate it all the way around so that it's facing that same direction toward the right that it was at the beginning, we call that a full rotation, and that has a measurement of 360 degrees. All other rotations are based on that full rotation amount. So if a full rotation is 360 degrees, that would mean that a half rotation, where the car faces the opposite direction that it did at the beginning, would be half of 360, or 180 degrees. And everything else follows from there. If I make a quarter turn so that the car is facing up instead of toward the right, well, that would be half of the half rotation. Half of 180 is 90 degrees. Let's talk about how we can graph an angle in standard position. We like to use Greek letters to describe our angles. So this first example is theta equals 90 degrees. Now if I want to graph a 90-degree angle in standard position, I must start with the initial side along the positive x-axis, and then I rotate from there. Positive angles rotate counterclockwise, negative angles rotate clockwise. 90 is positive, so I need to make a quarter turn, a 90-degree rotation in a counterclockwise direction, and wherever I end up is where my terminal side lies. The little red arrow is called the rotation arrow, and it's very important because it communicates the amount and direction of the rotation. Let's try another example. The second example says alpha equals negative 270 degrees. Well, I'll put my initial side always along the positive x-axis. This time I have a negative angle, so I'll be rotating around in a clockwise direction. Let's see, 270 is a multiple of 90, so 90 degrees, here's 180, and then 270 is 90 more than 180. So my terminal side once again lies here along the positive y-axis. Here is a picture of negative 270 degrees in standard position. Again, remember, you need to have an initial side, a terminal side, and that rotation arrow. If you look at the bottom, we've got a definition here for coterminal angles. Coterminal angles are angles that end up in the same place, that have the same terminal side. And so 90 degrees and negative 270 degrees would be coterminal angles. All we're really saying is that there are different ways to rotate and end up in the same place. Think about the car. When I made that quarter turn, I rotated 90 degrees in a counterclockwise direction. But I could just as well have rotated 270 degrees in a clockwise direction and ended up in the same spot. Or I could have gone really crazy, spun it around counterclockwise a full rotation, added in another quarter rotation, that's 360 plus 90, 450 degrees. 90 degrees, negative 270 degrees, 450 degrees are all coterminal angles. Let's do one final example. Beta equals 560 degrees. I'll mark my initial side. Now let's see, 560 is more than one complete rotation. It might even help me to know how much more it is. So let me subtract 360. And of course what's left is 200 degrees. So what I need to do is I need to rotate all the way around counterclockwise and then keep going another 200. Well, here's 90, 180, 20 degrees past 180, so not too much. And my terminal side then will be somewhere about here. Here is 560 degrees in standard position. Okay, just a couple of last comments. We say that angles lie in the quadrant in which their terminal side lands. Remember how we number the quadrants in the XY plane? So we have quadrant 1, 2, 3, and 4. For that last example, beta equals 560 degrees, we would say that angle lies in quadrant 3 because the terminal side landed in quadrant 3. What about our first two examples? Those terminal sides didn't land in any quadrant. Well, in that case, those angles are called quadrantal angles, angles whose terminal side lands on either the x or the y axis. 90 degrees and negative 270 degrees are both quadrantal angles. Thanks for watching.